Did you know that digital footprints on Linux and Mac systems can be harder to trace than on Windows? Investigating these platforms requires different tools, different commands, and a deeper understanding of unique file systems. In this video, we're unpacking Chapter 7, Linux and Macintosh. File Systems from the Guide to Computer Forensics and Investigations, 6th edition. Before we dive in, go ahead and like this video, subscribe to the channel, and share it with classmates or colleagues. Every click helps more future cyber investigators find this content. Windows may dominate most desktops, but in the world of digital forensics, Linux and macOS are equally important. They're widely used in enterprise environments, servers, and personal computing, so understanding their file systems is crucial. Let's begin with Linux. Most Linux distributions use ext3 or ext4, which are journaling file systems. This means the OS keeps a log of changes to files and metadata, very useful when you're tracking suspicious modifications. These systems rely on inodes, which store metadata about each file: owner, permissions, timestamps, and pointers to the actual data blocks. As an examiner, being able to locate and interpret inode structures is vital. In practice, if you're working a Linux system, begin by mounting the image read-only. Use a forensic Linux distro like Kane or Kali to prevent contamination. Then explore directories like /var/log/ for logs including login attempts, system messages, and kernel events /etc/ /passwd and /etc/ /shadow for user account and password hashes. Bash _history files in user directories to see recent command line activity. Useful commands include grep to search for strings in files, find to locate files by name, and stat to pull metadata. You can even use rsync in forensic mode to safely copy file structures for further review. Next up, macOS. Legacy systems used HFS+, but now APFS is standard. APFS supports snapshots, strong encryption, and file cloning. These features protect the system, but can also obscure activity. Forensic analysts need tools like BlackLight, MacQuisition, or X-Ways to handle Mac imaging and analysis properly. Important locations on macOS include /users, /username, /library, for app data, preferences, and saved states. Plist files that record application usage and user behaviors. Time machine backups, often stored on external drives which contain full snapshots of system states. If a Mac is encrypted with FileVault, you'll need credentials or a recovery key to proceed. However, if you acquire the system while it's still running or capture a memory dump, you may be able to access decrypted contents. Always document these efforts meticulously. When handling Linux and Mac systems, you may find terminal-based acquisition is the only route. This means using DD or DCFL-DD to capture forensic images, mount to attach volumes read-only, and utilities like strings, hexdump, or XXD to interpret raw data. Pro tip: practice these in a lab. Set up a Linux VM, install apps, generate artifacts, and then analyze them. Do the same with a Mac if possible. The more hands-on you are, the better you'll understand log behavior, metadata, and user actions. One major legal and technical challenge in both systems is encryption. FileVault and LUKS can block your entire investigation. That's why live acquisition, when a system is powered on, is sometimes your only chance. Make sure to isolate the device, capture memory, and preserve everything before shutdown. In summary, Linux and Mac forensics require a deeper technical understanding and greater comfort with the command line. These systems hide their secrets well, but with the right tools and training, you can uncover them. If this video helped clarify how forensics differs across operating systems, be sure to like, subscribe, and share it with your cyber community. And here's your call to action. Comment below with the OS you'd least like to investigate: Linux, Mac OS, or Windows, and why. Next up in Chapter 8, we'll look at mobile devices and how they play a central role in modern investigations. Until then, stay sharp, stay curious, and always stay forensic.